demarcation process, which is used to outline V1, which is the primary visual cortex, V2, which is not surprisingly the secondary visual cortex, and V3, which is the tertiary visual cortex. And so the same way that we know where the primary and secondary and visual tertiary visual cortices and the quaternary visual, which is the fourth visual cortex, the same way that we know where these brain areas are is through a demarcation process similar to this, and it's consistent with previous research that shows that the peripheral visual field is actually 15 degrees, and the peripheral visual field is up to 60 degrees, and the central visual field is from 0 up to 15 degrees. And by doing this, what we have is we have some ambiguity and discrepancy about where the central and peripheral visual field lies. Some people will do it 2 degrees less, some people will do it 2 degrees more, and say that this is the central visual field, or this is where the peripheral visual field starts. There's a fluctuation of 2 degrees more or less. What I like about this is you are using retinal stimulation of the area of the eye, the retina that receives light, that is then going to correspond with the brain in the same or in a similar demarcation methodology used to outline V1, V2, V3, the visual cortices, the early visual cortex. So what I like about this is a high specificity, a higher level of exactitude. The word science means to know. Sci means to know. In means pertaining to the qualities of, and CE means the qualities and characteristics of. What happens here is if the visuals being supplied to the mouse human mirror neuron system have a fourfold heavier dependence on the central visual field, or a fourfold heavier reliance on the central visual field, the female's human mirror neuron system is going to presume that the male is gawking, because her embodied simulation is coming from fourfold more global peripheral visuals with the global peripheral visual field. And as a result of that, this male's attention that's brought down by 15, 30, 45 degrees to just this central visual alignment to look at you in a direct way is over, plus the steering is done for too long. Now, why is it done for too long? With central vision and stereopsis, which causes males to steer as a result of having central vision, what you get is intraocular suppression. And this means that in turn you get binocular rivalry, bi meaning two, ocular meaning to see with the eye. So you get binocular rivalry in that the two eyes that are working together in stereopsis cannot attend to two separate visual targets. So they have to swap and switch between visual targets. And this means that the male central visuals, and you'll see this when you look down the kitchen roll tube. If you look down the kitchen roll tube that's in your kitchen, you're going to do what you're going to do. So if you were looking down the kitchen roll tube, what you're going to see is that because the periphery is cut off, you will look directly, and then you will switch between visual locations. You will pre-allocate your visual attentionality to the upcoming visual targets, and you will connect them together using your visual working memory. That is the working memory that takes a visual every 300 to 500 milliseconds. Milli being a thousandth, like millimeter, a thousandth of a meter, milliliter, a thousandth of a liter of orange juice, a millisecond, a thousandth of a second. So this is what happens every 300 to 500 milliseconds. Bibliography 53G in the unabridged version of the book. And what you will find is where these images are taken from. This is taken from the abridged version of the book. These same images are also in the unabridged version of the book. Most of the images are in the same. The unabridged version has more images, but you can find all the relevant. Or most of the images are also in the abridged version as well. What this does is it means that the male has to attend to different visual targets. So what you see here on the screen on the left with these beige explanatory visual demarcations of the male's central visuals that are targeting these visual locations on a woman's body that he's attracted to, who he's ogling at, and who he's gawking. This is why the central visual switch here is not to communicate attraction. It's not to be socially inappropriate. In the female's human mirror neuron system, where there are fourfold more visuals, peripheral global visuals, the female believes through bouncing that off of her own motor repertoire that if she was looking in that way, she would be looking to the exclusion of all else, all other people's social impressions of this gawking, and this undivided visual attentionality would mean that she is completely besotted, and this is at the center of her emotional prioritization, the visual information which her brain is processing and in turn concerned with for this moment. And so she would go over and approach the person. This is why females expect that if men are gawking, there's a part of them that still expects, despite overwhelming evidence that they will not approach, still expects them to go over and talk to you due to staring at you. But the man is not staring at you based on your visual motor repertoire. The male is staring at you based on a central visual version of the world, a central visual version of that same social event, wherein he is staring at you like that and gawking at these different visual locations in order to see. Now, there's a lot more that goes into that, and it's more that we're going to cover in upcoming videos, but it is absolutely convergent with what we have discussed here. So when we look at the neurochemistry, females have more GABA and they produce more adrenaline due to a ovarian steroidal neuropeptide called estrogen, because estrogen is a neurotransmitter and it's also a hormone, which makes it a neuropeptide because it's both, and it is a steroidal hormone and a steroidal neurotransmitter, which makes it a steroidal ovarian steroidal neuropeptide. And this creates more noradrenaline at the locus coeruleus of the brainstem, which is and more grey matter, which is the processing power that the brain uses to process the information. And what happens here is the female's visual system is called what is called a landmarking visual system. From various researchers, they converge on this idea that the females, and on the evidence that the females have a visual landmarking system and males have a orientation visual system, is that the females' visuals are integrating information from the global periphery. And the GABA is used for deliberate actionality so that the females can choose what to focus and target, which makes them have a cognitive visual system, which can see more of everything at once. So at any given instant and at any given glance, the female sees more than a man does, significantly more. The peripheral visual field is significantly larger than the central visual field is. And what's more is to be able to use the global peripheral visuals. Females still see faster than males. Again, that's something we're going to get into in future videos, but females start visually processing information earlier than males. They recruit more brain areas. They categorize that information more efficiently. Efficient means to do with minimal effort and complete and accomplish quickly. The combination of these two words is what efficient means. Females have a more efficient visual process than men, despite seeing manyfold more than what men are seeing clearly and canically, and that being integrated in parallel per instant. but we're going to get into more of this. The female's brain is a lot more visually intelligent, so this also means that the female wouldn't steer and gawk for as long, and she can attend to more of the male's material physicality. She can visually tend to more of the male's material physicality much better at a glancing with a shorter look, and she and categorize this information to visual memory better, more efficiently, and retrieve it, which is information we're going to go into. The male, however, has significantly less ovaries, and in turn males have significantly less estrogen, and in turn males have significantly less noradrenaline in their brain and significantly less grey matter than females. What does this mean? Well, visual information that the brain can consciously concentrate on is integrated into the parietal lobe using noradrenaline. Noradrenaline is what integrates visual information. Without this, you can get what's called cognitive tunneling, which is effectively it is tunnel vision, which is central vision. And cognitive tunneling, or the ability of the brain to block out other information that it's not directly focusing on, so it enhances the contrasting, the contrast of the information that isn't focused on. It enhances the information that is being focused on. It's called contrast enhancement. What happens here is this is done by acetylcholine. The acetylcholinergic signals in the brain that males are more sensitive to, and males synthesize more acetylcholinergic, more acetylcholine, and they're more sensitive to the acetylcholinergic signaling in the brain. This causes lateral inhibition, or what's called surround inhibition. Inhibition means to inhibit, lateral means side, surround means surrounding. It inhibits the surrounding nerves. So once the main nervous signals have come in from the central visual portion of the retina, the periphery is actually further blocked out by the male's acetylcholine. So even though the eye anatomy has caused around a fourfold greater, heavier reliance on the central visuals in men, the set specific neurochemistry of the brain further enhances that effect. In the females, noradrenaline is further integrating visual information or sensory information for this matter. Whereas in the males, it's blocking this information out. And what happens is when the male sees an attractive female, the catecholamines are released, which include noradrenaline, which is a type of adrenaline that occurs in adrenaline rushes, and that can be blocked with GABA, which females also produce more of. But acetylcholine, which is the male's version of directing their attentionality in a conscious way. GABA is what your prefrontal cortex uses to inhibit your amygdala and your limbic and fight and flight areas of your brain that make you emotionally impulsive or contribute to emotional impulsivity. And what happens is the male's visual system is using an acetylcholinergic aspect to a much greater degree, and acetylcholine is bypassed by the noradrenaline. So when the male's attracted to the female and he looks at her face and he looks at her bust and he looks at her legs, this is the noradrenaline aspect of visual attraction. You have what's called the brainstem. There is the locus coeruleus. It synthesizes noradrenaline. This information connects to the emotional area of the amygdala and of the insula and of the cingulate cortex, which is integrated, and the thalamus, which is where all the sensory information aside from smell converges onto the thalamus. And what happens here is the brain, locus coeruleus, causes hypervigilance, and it integrates the exteroceptive, the external environment, into the interoceptive, the internal environment of the body. So internally, we can feel this about that. It connects the external and it connects the internal and the external world, and this happens within our visual nervous system, within our visual systems. And so this is what the salience network is doing, and this noradrenaline is something that the male's acetylcholine cannot regulate. So males have what's called a bottom-up visual system, emotional impulsivity. So if something is salient, and so if it's prominent and it grabs your attention, when it grabs the male's attention, what happens with this is when it grabs the male's attention, the male is compelled to look and see. And this is where the male looks at the bust and then looks back at the face with his central vision. It's a very clumsy move. It's something a lot of males do in a female's context of having the global peripheral visuals and not having this tunnel vision and not seeing the central visual version of the world. It's a curiosity that females don't necessarily comprehend naturally. They can't comprehend it naturally because they don't have that. They don't have those central visuals. Females don't have 38% more macular photopigment, and they don't have 40% less of the peripheral visuals. And as we go into more videos, you will see that that is the tip of the iceberg. There is more to this than just that. And so the human mirror neuron system of the female is where her brain's cells, which are neurons, are brain cells, and the mirror is used for reflection of ourselves and others. The brain cell creates a visual reflection from the visuals of the external world from the male, and connects that with her own motor repertoire, which is a visual motor repertoire in the female based on eye anatomy alone, 80% or fourfold more of the peripheral global visuals to comprehend the male's social actionality and even to respond to it, to the social actionality, which is in part done by the action preparation network, which is also part of the human mirror neuron system. And you can see that information on bibliography 359N. So what we have here is from the human mirror neuron system, the default mode network attaches the internalized calculi and schemata to comprehend someone else's actions. While the human mirror neuron system has done the embodied simulation, the default mode network makes a high-leveled inference with internalized information, which makes the human mirror neuron system a self-projection on its own. You were taking the male and the females, respectively, are taking their own central, local, or global peripheral visual versions of the world and the social events within the world, or on the world, or within the world, into their own motor repertoire. And from their own motor repertoire, they're gaining the comprehension of what those actions mean. But what those actions mean only correctly applicable in the context of themselves. They are not directly connected to the brains of other people. The visuals of other people are being bounced off their own motor repertoire. That makes this information self-relevant. It makes it self-referential. They're referring to themselves for the information to infer what the other person is doing. They're referring to themselves when they make a simulation, which is embodied. They are making a mismentalized, they are miscomprehending. This is, to an extent, this is psychic equivalence, which is called the breakdown of mentalization. This is when you are not mentalizing what a person's actions and intentions actually mean. You are inferring your own, and to an aspect, this is psychic equivalence, where you take the information in your brain, be it emotional, and the emotional reasonings and decisions and judgments that you've made with this information that's inside of your brain, your own sensory evidence, your own sensorium, and you have relied on it with an unsettling level of certainty, which puts it into black and white thinking, where there is no room for the alternative interpretation. And that is because the nervous signals from the autonomic nervous system, which make emotions, by being integrated into the to the nodes of the brain that process emotions: amygdala, insula, hippocampal formation, cingulate cortex. These areas that form emotions in the brain. These are formed with the autonomic nervous system, which is the conjugation of your collective nervous system as a whole. Is your autonomic nervous system. And what happens here is they're not only causing emotions. These emotional areas then recruit the frontal areas of the brain, like the prefrontal cortex, the orbital frontal cortex. The prefrontal cortex is recruited. The dorsal medial prefrontal cortex by the insula, by the amygdala, and these emotions are integrated here. And this is what causes your prefrontal cortex dorsal medial. Dorsal means top, medial means medium, from medium, which the medium is the middle. So it's the top middle part of your prefrontal cortex. It's integrated into this area for categorization and contextualization, but categorization also to categorize what these emotional states that are occurring in your body that have triggered your autonomic nervous system to send signals up to the brain, which induce the emotions, so that the emotions can then be categorized. So now you can comprehend what is the problem in your external environment, what is the salient, prominent aspect of our external world, which is grasping our visual attentionality right now. What is that? And so from here, this is an aspect of your default mode network, which is necessarily directly connected to the human mirror neuron system. And this is where you can make this high-level inference from these kinds of contextualizations. From there, the prefrontal cortex goes to the hippocampal formation, which is made of the entorhinal, pararhinal, parahippocampal. Collectively, it is considered the epicenter of memory within the brain. And your visual association cortex networks with your prefrontal cortex, which works like a switchboard of categorization and links to the area of the brain where memory occurs and visual memory occurs, visual working memory at the parahippocampal place area or parahippocampal scene area, a combination of the occipital visual area and the memory area, which enables recognition as well as storage of information and from memory to recognize. Re means again, co means to gather, so it's to gather again. GNO or GNI means to know. And eyes is being endowed with the characteristic of. So it is to know again, is to regather again, to know. It is the action of doing that recognition, to recognize what we've seen again. These are the Proto-Indo-European factual meanings of words, and that's in bibliography 347. With the unabridged version, you will find those words, any word that I've explained etymologically as its root definition, which is largely what occurs in science, as we use root definitions a lot more than we do in day-to-day colloquial language. You'll find that in bibliography 347. And so this inference of what other people are doing is being made purely from the human mirror neuron system and default mode network exclusively, which form the basis of human social cognition. And this causes the female to think that the male is gawking, because she would be gawking, and even to expect that he will approach, even though there's overwhelming evidence statistically, empirically, the male will not approach just because he's gawked at you. The vast majority of males, statistically based on empiricism, which is self-observation that you've observed, he does not approach. And that's because he has central vision, he is looking to see. And he has the emotional impulsivity in his neurotransmitters, whereas in the adrenaline that's produced is one of the catecholamines when he's attracted. Bibliography 187b, as a neurochemical, when he's attracted, these catecholamines cause him to look impulsively, because he can't. The acetylcholine is bypassed by the neuroadrenaline. Bibliography 169 BC and 269 BC and 271 BC. The neuroadrenaline bypasses acetylcholine's inhibitory effect. But this doesn't occur with GABA. Bibliography PVC. This does not occur with GABA of the unabridged version. Anything above 13 is the unabridged version. The bibliography, the highest bibliography, 13 is as far as the bibliography goes in the abridged version. The unabridged version goes farther than that. So you can see here a visual line. This is a visual line whereby this is to make an explanatory illustration that clearly demarcates what the male can see clearly, and this bin is clearly defined while the women at the bus stop are not. They are faintly visible, and this is to show you that this is what the male can see, and while he's not looking directly, he has significantly less peripheral visuals than a female, and so he's seeing a central visual version of this world, and the male's going to have to do what you see on this left image here, which is direct his visual attentionality given target locations in order for his visual working memory to take snapshots and build up a picture of these abstract visual encoding instances into his brain across every 300 and 500 milliseconds. So first he's going to look at the female's face here, and then he's going to look at the female next to you, and then he's going to look at the next female's legs, maybe, and then the next female. And what even as you see on the fourth image, where he's looking at the fourth image, when he's looking at the next female, as he's walking along, you can see like 1, 2, 3, 4. He's walking along 4 steps. He's looked at 4 visual locations. His visual central visuals are moving around. Even from there, he alternates to visual target locations on that woman to see her abdomen and torso, and to see her legs here as well. Yeah, abdomen. And this central visual version of the world operates a 0 to 15 degree field of vision, which is to say that the visual locations are being constantly redirected. This is to say that the male has to constantly reallocate and reorient his visual attentionality and pre-allocate his visual attentionality to different visual locations, and then again reorient his central visuals. The males have what is called a central visual orientation system, whereas in females have a peripheral global visual system, which is called a landmarking visual system. These different visual systems being used by the human mirror neuron system in these different motor repertoires necessarily lead to these instances through the human mirror neuron system and embodied simulation and high-level inferences of the default mode network. where you can read more about this information in Bibliography 0.0. The book CVP specifically covers a much heavier male-centric aspect of the visual system. PVC has more information, and it covers this bibliography specifically covers a very female, woman-central centric version, locus coeruleus of the brainstem, which is and more grey matter, which is the processing power that the brain uses to process the information. And what happens here is the female's visual system is called what is called a landmarking visual system. From various researchers, they converge on this idea that the females and on the evidence that the females have a visual landmarking system, and males have a orientation